Our project is a web application for media store management system. This system is for stores which sell and rent books, video games, movies, and music. However, the system is not limited to these four types of products. The flexibility of our database design allows store owners to easily add new media product categories in the future. Furthermore, each product type may have different attributes. For example, movies have actors and books have authors. To implement this project, we will use a LAMP stack as our backend system. LAMP stands for Linux, Apache, MySQL, and PHP. Our Apache web server handles client-server connections and all HTTP requests. Its ease of configuration helps us to focus on implementing business logic and database design. We use PHP as our web development language because it is one of the most popular interpreted languages for server-side web development. Since it is an interpreted language, debugging is easier and compilation is unnecessary. Our database management system, MySQL, is an open-source relational database with a large community for support. MySQL has a popular database engine called InnoDB, which supports transactions. For front-end development, we use Twitter Bootstrap and jQuery. Bootstrap makes designing websites efficient by providing reusable components, and jQuery helps us handle user events with ease.
Application requirements. There are two types of users, store owners and employees. The actions between entities that are repeated are the following. Employees can receive, move, and sell products from inventory. Selling would entail transactions conducted by employees. Employees can search for specific transactions as well. A store owner can add new products and remove or edit other products. The store owner can also do everything an employee can do, except conduct transactions. Customers can make numerous amounts of purchases and rentals. Users have the ability to search all available inventory for any specific products, search for total sales of a certain product, and search for customers with overdue rentals.
Since this is a data-centric application, we need constraints on this data in order to maintain the integrity of the database. Our main entity in the database is going to be products, and so these have several attributes that must be constrained. Attributes that identify particular products, such as the UPC or the ISBN number, must be unique so that different products do not share the same identifiers. Also, certain attributes such as title should be not null because we want to be able to easily search this database for information such as the title of a product. There are also important relationships between the products in this database and the other entities, so we need constraints on those relationships. Every inventory item makes foreign key references to products. Every transaction has a valid employee and customer and references foreign keys of one or more products. Each movie or book has a valid actor or author, and each product is added by an owner.
This is Jessica Armstrong, and I'll be taking us through the ER diagram, part 1. So we'll start off with the product entity, which has 3 attributes associated to it: the genre, the title, and the UPC, which is sort of like a unique ID for each product. That's going to be our key attribute for the products. So each product is going to be divided between a movie, book, game, or music product. And the movie entity has a release date as an attribute and has the relationship with an actor. And now a movie can't exist without its actors, so that's going to be a weaker relationship, many to many. The actor has a name and a birth date, which are going to be its key attributes, and we move on to book. The book entities have ISBNs, also unique to books, and ID to let us know which one is which. They're written by authors and can't exist without their author. The author entities have also name and birthday, similar to actors, and those are going to be key entities. So gaming, all games are going to have platforms, and music is going to have the artist attribute. So a product has an inventory item. Inventory items are weak entities that have a one-to-many relationship with products. Inventory entities cannot exist without products, so that's why they're weak. We have an inventory ID, location, total available, total rented, and condition to tell us where the product is in the store and what kind of condition it is, and the purchase price and rental price that are going to be associated with this entity will tell us how much that product is going to be based on the condition.
User entity have for attribute user ID, name, address, and phone number. User ID is the key. The relationship between user and inventory item is many-to-many. This is because user can update multiple inventory items, and an inventory item can be updated by multiple users. Users have two different subclasses, employee and owners. The relationship between owner and product is one-to-many. Owner can add multiple products, and a product can be added by one owner only. Double error also means that a product cannot exist without being added by one owner. Transactions have transaction ID, payment type, and total cost. The relationship between transaction and customer is one-to-many. Transaction must have one customer, and the bold line means that the customer have to have at least one transaction. Transaction must also be conducted by one employee, and the transaction cannot exist without having at least one product. Customers have to attribute name and address, and they are both keys. Transactions have two different types, purchase and rental. Rental have due date attribute.